Hello students, Professor Nugent here. In this video we're going to discuss outliers and influential observations. OLS is sensitive to outliers because a large residual that results from an outlier is squared, so it receives a lot of weight. A particular observation will be influential if the results, the estimates, differ by removing that observation. Outliers can result from many things. A few of those, an example of these things include mistakes, so including too many zeros, from sampling from a small population, or outliers could be from completely different populations, but have been included in a sample also by mistake. Now, some economists prefer to begin data cleaning by Winsorizing to help fix this. Winsorizing implies removing the lower and upper 1% or 5% of data. That may depend on how large your sample is and the extent of outliers. And it can be useful to do the analysis with and without Winsorizing. Winsorizing is just one way to fix it. Another way to fix is to trim. So you can trim particular observations. We can try to identify particular observations by characterizing an outlier using a studentized residual. The studentized residual is the size of the residual, and recall the residual is the distance between the observation and the regression line. It's the size of the residual divided by the estimate of a standard deviation. There's a neat trick that we can do to estimate the size of the outlier and the studentized residual. We can get this by denoting a dummy variable. Let's say D is equal to 1 for observation H and 0 otherwise. We can interpret the dummy coefficient as how far the observation is from the regression line obtained without the use of the observation. And then the t-stat on the dummy variable is the studentized residual for the observation. The t-stat is distributed. Stat of the dummy variable is distributed t n minus k minus 1, and so a large t-stat implies that the studentized residual is large relative to the estimated standard deviation. If outliers are particularly problematic, we may wish to move away from OLS and instead use the least absolute deviations estimator or quantile regression.